Before I start, I just want to kind of say two things. One, thank you so much to Louis and Jesse and Christina and Michelle and Akbar and Cecilia for organizing this event and for inviting me here and having a chance to interact with all of you. And second, the title of the talk is maybe a bit misleading because it kind of suggests that there is already a well-established kind of field of this kind of what cooperative AI is, and there is a well-established connection between fairness and cooperative AI. And obviously, since the field of cooperative AI, as Louis mentioned, we are still kind of trying to figure out what cooperative AI is. Obviously, there is no well-established connection between fairness and cooperation, and so my main area of research is algorithmic fairness, and I just kind of noticed some high-level connections between fairness and cooperation, so I've tried to put them together in this talk. So it may not be as kind of structured and kind of not all the connections might make sense to everyone, okay? And you might disagree on whether this particular aspect of fairness is related to the idea of cooperation or not. Okay? Also, I'll try to cast a bit broader net instead of just kind of talking about how fairness can lead to cooperation. I'll talk about more broadly who are the humans or the agents that we want to cooperate with each other. Why do we want them to cooperate with each other, and then how do we get them to cooperate with each other? And it is in the answer to the third question that kind of fairness will pop in. All right, so here's the high-level kind of outline for the presentation. I'm going to start by talking about what is cooperation in the first place, and how do we think about cooperation, how do we reason about it, how do we try and define cooperation, and whether we need to define cooperation, okay, in order to train our AI systems to be cooperative. Then I'll try to motivate fairness as a building block for cooperation, and then kind of demonstrate that in certain real-world applications. I won't have time to go over kind of all the different applications where this particular notion of fairness that I want to talk about today has already been applied to, in some sense, induce or foster cooperation. So I'll just select some real-world application and then kind of give pointers to other applications if you are interested to check out. And then I'll kind of answer these other questions of who and why we want kind of cooperation to happen, and end with some takeaways or food for thought. Okay. Yeah, there we go. All right, so what is cooperation? And before we answer that, we need to answer whether we need to define cooperation. And I've been talking about this problem with a lot of different people. And so if we want our AI systems to be cooperative, and if we, okay, here we go. If we want to train them to be cooperative, there are three primary approaches more or less nowadays. The first is a theory-led approach, where you essentially find a concrete definition of cooperation, maybe kind of a mathematical definition, or maybe slightly kind of maybe a reward function or something like that, and then you just feed that to your AI system, and then kind of it trains to kind of satisfy that definition, and it becomes cooperative. And often these definitions are based on human intuition, but also some kind of logical grounding or moral grounding or some philosophical grounding, because human intuition often is kind of very conflicting and sometimes logically inconsistent. Another approach at the bottom is to just directly get data from humans. So don't care about what cooperation is. Humans have some intuitions about what cooperation is, and just maybe show the actions of your AI to some human annotators and ask them whether this AI is being cooperative or not. And they'll kind of use whatever intuition they have in their mind to give you some labels, and you just feed that into your system in some form of supervised learning or RLHF, and then your AI system is magically cooperative, according to whatever the kind of human society collectively thinks cooperative means, without you having to figure that out. And then there is nowadays kind of a middle ground approach, which is not using direct data from humans, but in some sense kind of indirect data from humans, where if you have an LLM, you can just tell your LLM, I want you to be cooperative from now on, right? And then what it will do is it will basically kind of use the corpus that it's trained on. Maybe kind of people have expressed what cooperation means to them in some kind of online forum somewhere, and kind of there's a lot of all these intuitions have already been spelled out, and then based on those intuitions, it will figure out what people might kind of mean as what people might mean by cooperation, and then it will try and achieve that without, again, you, the designer of the system, having to figure it out. And so certainly, for the first approach, you need to know what cooperation is. You might think that for the other two approaches you don't, but I would like to argue that often it is the case that even for those two approaches, it helps to have some idea of what cooperation is, because often if you want to kind of prompt your human annotators, or if you want to prompt your LLM to kind of think about cooperation, it helps to lay down some foundational building blocks of cooperation. Sometimes, for example, when you tell your human annotators that here are kind of different things that other people might mean by cooperation, they might look at something and they might say, you know what, that's right, I hadn't thought about that. I agree that that should be a kind of one of the criteria for cooperation, right? So it helps to know what we might mean by cooperation. And so that's what I'm going to do, but primarily I'm going to stay focused on this first approach, the theory-led approach, and I'm going to try and kind of reason about cooperation mathematically. So let's say we want to define cooperation, and if you look to the literature, some of the simple definitions that are available, one of the simplest definitions is that whatever gets you to kind of maximize the total utility of some group is being cooperative with that group. Okay, and so Lewis kind of in his informal definition of what cooperative AI is, talked about collective welfare, and so this is kind of one definition of collective welfare. You can replace kind of the sum of the utilities with some other function, but generally kind of there is this one family of definitions that say I want to kind of maximize some sort of collective welfare, and if you are doing that, then you are being cooperative. And I would say that this is too simplistic and too restraining in some cases. For example, if there is an agent who can take some action, and this action may be better for some group as a whole, and for example might be increasing the total utility of everyone in the group by some small amount, it may be okay if that agent doesn't take that action, and people might still find that the agent is not being uncooperative if that action is going to be coming at a significant cost to that agent, right? So society may not kind of dictate that I have to take on a significant personal cost at slight benefit to everyone else in the society in order for me to be cooperative. On the other hand, there are some actions that where there is a benefit to the society, there is no personal cost to me, and yet when I take those actions, this may not be counted as cooperative, because even though the total utility might be going up, all of that increase in welfare might be going to just a few individuals at significant harm to everybody else, right? So there are kind of this type of definition ends up being too simplistic, and there are kind of more facets to this that human intuition usually tries to capture. Another type of definition says that, well, let's look at some kind of game theory approach. Agents have actions, and I'm going to kind of label each action as cooperative or non-cooperative, and then it's very simple. If the agent is taking an action that's already kind of labeled in my input as cooperative, then the agent is being cooperative. But this is just really kicking the can, because now you have to find out a theory for how different actions can be labeled as cooperative or non-cooperative in a given setting. All right, so what I want to kind of motivate is that if you want to define cooperation, then you need to first go back to the drawing board and answer a bunch of really basic questions. For example, is this notion of cooperativeness, is it a qualitative notion or a quantitative notion? If it's a quantitative notion, is it a scalar? Is it a multidimensional attribute? Is it just enough to define what it means for me to be cooperative with a group? Or should I define cooperation with each individual agent and then somehow summarize that to kind of infer cooperation with a group? Should cooperation be a unidirectional notion where I can say that I am cooperating with Lewis, but Lewis is not cooperating with me? And then if I define it like that, is that any different from altruism? Or should it be a bidirectional notion where I say that for Lewis and for someone to say that Lewis and I are cooperating with each other, we have to take joint actions that are in mutual benefit, right? Does it have to be a symmetric notion? Should I label some collective outcomes that some certain agents are achieving in a system? Should I label those collective outcomes as cooperative outcomes, or should I label the individual actions of individual agents as cooperative or not? Or maybe I should take a step back and think of each agent as kind of part of a society where the agent might be engaged in several different games at the same time with different groups of agents, right? And so this agent has some underlying reward function or some objective function that they are trying to optimize, and that is what's leading that agent to play different actions in different games, right? And so really it's this underlying reward function of the agent that should be labeled as cooperative or not the individual actions in individual games that they are playing. Right, so all of these questions need to be answered, and sadly I have to say that I'm not going to answer any of these questions because I do not know the answer to any of these questions, but this is a great research project for someone who wants to take it on, and as a first step, it would be great to collect human intuition about the answer to all these questions. And there are already some kind of works in different literatures that try to answer this question, and so you can also look to these literatures for sources of inspiration. All right, so what am I going to do if I'm not going to define cooperation? Well, let me tell you about resource sharing systems, which is what I'm going to talk about for some part of the talk. So these are systems where some kind of collective resources are to be shared between a set of agents, and these resources could either be contributed by the agents themselves. So I'm thinking of some kind of exchange markets where agents come in with some set of resources, exchange these resources with other agents, and then hopefully leave with something that's at least as good as what they brought in, perhaps from their own perspective, right? Maybe each agent has a different way of looking at what's good and what's bad. And there are some easy examples where, say, Alice buys a 1 liter 1 liter carton of apple juice, but really wants orange juice. Bob buys 1 liter carton of orange juice, but wants apple juice. And then it kind of, for them, they should cooperate and they should just exchange what they've bought. Okay, so that's very easy. But then it becomes more difficult if you think of like Alice and Bob as having different amounts of different resources that they are bringing into this kind of exchange market, and now they have very complex preferences over what proportions of what resources that they want and how they are going to use those resources to generate some value. And in these exchange markets, you typically kind of the cooperation can be fostered or induced if you can make sure that the agents are not being significantly harmed by the exchange markets. At least a kind of a very primitive notion might say that each agent should leave the exchange market with at least as much value as they had brought in, where the value might be defined by each agent differently, right? So each agent may have their own preferences that define how much they value different kind of resources in different proportions, and according to their own valuation, they should leave the exchange market with at least as much as what they brought in. And this is typically viewed in the literature on fairness as some kind of fairness notion, because the agent is entitled to get at least that much value. But you can also view it as something that fosters cooperation, because if the agent is not getting that much, then the agent just will not participate in the exchange market, right? And in some sense, participating in the exchange market is going to lead to kind of collective benefit, because the agent has some resources which other agents might value more, and other agents might have some resources which this agent might value more, and so they are going to be able to achieve better collective outcomes if the agents participate in this exchange market. So there's some kind of connection between fairness and cooperation already kind of coming in here. Another kind of resource sharing systems are the type of systems where agents are not coming in with resources, but they are entitled to shares of resources. And so a simple example is, say, Lewis and I walk into a room, we see $10 lying on a table, and say we are kind of evil enough to keep those $10 to ourselves. But now because we both saw those $10 at the same time, we are kind of both in some sense entitled to having at least like $5 claim out of the $10, right? And so the cooperative thing for Lewis and I to do would be to split the $10 evenly and take $5 each. Right? And if Lewis is asking me for kind of more than $5 share out of it, then Lewis is not being cooperative, right? So this is something that many people might say, and this is also a sense of fairness that again comes in here. And so what we are doing here is we are not comparing what the agents are getting out of the system to what they are bringing into the system. but rather we are comparing it to what, in some sense, they are entitled from the system. Again, this is a very easy example, becomes a lot more complex if you think of this problem that I very often work on. A large chunk of my work is this particular type of problem. An example is estate division, where someone dies, they leave behind an estate but no will, and the estate consists of a whole bunch of items, a house, some furniture, some artworks, jewelry, etc. And then this needs to be divided between different heirs. And now it's not clear how do you define the entitlement of any agent, let alone the entitlement of a group of agents, because now there are kind of more than two people in this case. And then how do you compare the outcome that they are getting to their entitlement? And so those are the questions that I am going to at least give one answer to in this talk. All right, so just to make it clear, the type of systems I'm looking at are where agents have only two possible actions. They can either kind of choose to participate in this mechanism, where participate might mean coming in and agreeing to contribute their resources that they have in some kind of exchange market, or in the kind of systems where they are just entitled to some set of resources, participate might even mean that they just don't complain about it, right? They're satisfied with whatever outcome the system is giving them, and in that sense, kind of this participate action can be labeled as cooperative. Again, so this is kind of, I'm simplifying the problem here because I don't know how to answer the more general problem of how do you label something as cooperative or not. So in this system, assume that this kind of participate action is the one that's cooperative, and then not participate, which means to not participate in the exchange market or leave the exchange market or complain about the outcome and not accept the outcome. Let's say that this is not cooperative. And that might be for good reasons. So there is no kind of moral sentiment being assigned here to not being cooperative. Okay? But we do want to induce cooperation because that can improve collective welfare. All right. So the question is, how do you get those agents to cooperate? And there's this notion called the core, which originally starts from cooperative game theory and was often viewed as a notion of stability. Because you kind of wanted these agents or groups of agents to participate in the exchange market and not leave the exchange market, but is also studied very recently as a notion of fairness, because especially for these other types of systems where the agents can't really leave the market. I mean, if they leave the market, they are not going to get anything, but really they feel that they are entitled to certain kind of share of whatever collective resources are being divided. And it's this sense of fairness that I need to be treated at least as well as what I'm entitled to, or we need to be treated at least as well as what we are collectively entitled to, is this sense of fairness that the core is also trying to capture at the same time. All right, so what does the core say? It says that no group of agents should be able to Pareto improve over the current outcome using their collective entitlement. All right, so I'm going to define this more formally. But the one thing I want to clarify is that I'm not really, even though I'm talking about agents, I'm not really making a distinction between human, like biological agents or AI systems, autonomous agents, and because many of these definitions actually they apply equally to kind of all sorts of entities, entities that have some kind of objective function that might want to seek fairness. All right, so one thing about this definition is that it's trying to look at every possible group and every possible way in which they can take their collective entitlement, collective share of the resources that they are entitled to and divide it amongst themselves. And it requires that none of these divisions for none of these groups should be a Pareto improvement for those groups. All right, so a little bit of notation, just to kind of ground our discussion a bit more mathematically. Say that this capital N is the set of agents that we are kind of interested in, and this C is the outcome that is selected by our whatever mechanism we have in place or whatever institution we have in place, and we want to reason about whether this outcome C is fair or whether it's going to the mechanism that selects this outcome C on different scenarios is going to induce cooperation. And so we need to reason about how happy each agent is under this outcome. So we define UI of C as the utility that each agent I gets from outcome C. And then I'm going to want to compare how happy the agents are to, in some sense, what they feel they are entitled to. And so I'm going to do that by generically defining some set L of S, and this is going to be somewhat domain dependent, but kind of hopefully I'll be able to show you a whole bunch of different domains and kind of convince you that there is some kind of common idea as to how to define these entitlements. So L of S is the set of all possible outcomes that any subset of agents or group S can implement by taking their collective entitlements and just kind of dividing among themselves. And once we have some way to define this set L of S for every possible group S, then we can now define this notion of the core, saying that this outcome C is in the core if for every possible group of agents. So note that I'm not specifying kind of groups in advance, even though some of the other fairness definitions in the fairness literature do kind of require specifying groups in advance. They require saying, oh, I want to ensure fairness between, say, a set of white people versus black people, or men versus women, right? And this definition doesn't require that. And in some sense, that's why I like this definition, especially in the context of cooperation, because we may not just want to achieve cooperation between very specific groups of people. We might want to kind of induce cooperation more generally. And so here I'm going to look at all possible, if you have n agents to the n minus 1 many possible subsets. So for all subsets of agents and for all outcomes that they can implement using their entitlement, that outcome should not be a Pareto improvement over the current outcome for that group. And what that really means is that there should be at least one agent I in that group who doesn't prefer the new outcome over the currently selected outcome. All right, so at least this one agent wouldn't have an incentive to join this group and kind of break off from the current system if it's an exchange market, or join this group in complaining about the outcome of the current system, that this group is not being treated fairly, because this agent would say that if we are proposing this as the alternative outcome, well, I mean, the current system is treating me at least as well. So maybe let's try and find something where all of us are better off, and then I will be able to, we can all kind of join in and complain about the system. Right? And so in some cases, this may not be achievable. You may be able to show that there are no outcomes that satisfy this, and then you might need to relax this notion, and there's some kind of approximation you can define. You introduce a factor alpha and say that at least it should not be the case that a group is able to achieve a significant Pareto improvement over the current outcome. Right, but you don't really need to worry about the exact relaxation. All right, so with that general framework in mind, let me try and motivate that definition through a bunch of different, very different domains. Okay, so this one thing I like about this definition is that it's the same definition that applies to a lot of different domains, and in all these domains, it ends up being meaningful. So it tries to capture some reasonable notion of what fairness means, and in this particular context, because it's kind of trying to keep these groups together in this larger system, kind of get these groups to cooperate, and it is highly non-trivial. So unlike some of the other definitions where kind of, yes, you might have a trade-off between some form of efficiency and some form of fairness, but if you just care about fairness, then you can achieve that very trivially. Here, just this notion of fairness itself ends up being very, very non-trivial to achieve, even if you don't care about anything else. All right, so let's talk about clustering as an example domain. And clustering can be used in very different applications, and depending on the application, you might seek very different types of clustering solutions. So let me talk about kind of one application, one type of application in mind. So think of public facility location, where a city wants to take the locations of where its residents are living, and then cluster those locations in order to find some K cluster centers. And these are the locations where the city is going to build K new public facilities, say schools or hospitals or parks or things like that. And now, so we can kind of redo the general setup in this framework. N is our set of agents, or in this case, human residents, or you can also think of them as the AI agents that represent these humans, if they have them. And they have some locations in an underlying metric space. And let's say D is the distance metric of this metric space. and C is the, say, some current clustering solution that has been chosen by the city. And so these are just K locations in the metric where the city is going to build these schools. And the utility of each resident I for this solution is just is dependent on the distance to the nearest school, right? And so because it's utility and distance is kind of negative thing, you just have to put a negative sign. And there's a star there because when I talk about relaxations of the core, now kind of multiplying this utility by some number alpha, say alpha equal to 2, is actually going to not increase the utility but decrease the utility because the utilities are negative. So you have to multiply by kind of the inverse of alpha, but again, you don't need to really care about that. The relaxation of core, the alpha core definition slightly changes for negative utilities. All right, but what I'm more interested in is what it means to have some form of entitlement. And so these schools are plausibly going to be built using some tax dollars, and there might be there is usually kind of a normative normative goal in our society that the tax dollars should be spent equitably, right? And so each resident, you can think of them as having kind of an equal share of the tax dollar, an entitlement to an equal share of the tax dollars. And so if any group S of residents come together, then they have that proportional share of the tax dollars that they should be entitled to. And so, and using that, they should be able to kind of get a proportional share of the schools built that serve them, right? So if we are going to build K schools, and if you look at any 20% of the residents who come together, 20% of the schools should be serving them, some 20% of the schools, right? And in particular, what this L of S is essentially any locations for 20% of the schools that they can find. And if those locations serve this 20% of the population better, then somehow you are not doing justice in your original solution, and this group might come to you and complain. Yeah. If you take any 50% of the population, and if they can find better locations for 50% of the schools, then again they might come to you and complain. Yeah. And so that's what we are trying to achieve here. We want to make sure that no X% of the population should be able to find better locations for them with X% of the schools for any X. Right, so here is an example. Say you have this hypothetical city where some 600 people are living in one kind of very tightly knit cluster over here, 200 people are living over here in one tightly knit cluster, 100 people are living over there, and you want to build 3 schools. And so a standard clustering solution like K-means clustering, for example, might, because it's trying to do something different, it's trying to just kind of detect where the clusters are. It might kind of put the cluster centers, one there, one here, but this wouldn't be proportionally fair or wouldn't satisfy the core because that cluster over there are 600 people living there, which is 2/3 of the population. So they feel entitled to having 2/3 claim over the collective resources using which the schools are being built. So they might feel entitled to having 2/3 of the total number of schools, which is 2 schools, serving them. And so the only the only solutions that will be in the core would be to put 2 schools in that cluster over there, and then 1 school somewhere in between over here. Okay. Right. This is not the kind of solution that you want in all applications, but there are certain kinds of applications where you want this type of proportional fairness. And then there was an ICML19 paper that showed that this type of core solution in this clustering problem may not always exist. There are counterexamples where no solution satisfies this fairness requirement, but you can get some kind of small multiplicative approximation of it. So no group can come together and find something that improves the utility or kind of like reduces the cost of each member of the group by a factor more than 2.41. And this holds for any distance metric D. And then we had this paper a few years back where we showed that if you care about the standard Euclidean metric, then actually this can be improved to a factor of 2. And then there are some kind of other learning theory results and this and that if you're interested in checking out. All right. The results matter more. The results matter less than just kind of me trying to make a point that this definition seems to be applicable in a lot of different contexts. So here is a very different context. It's participatory budgeting, and this is a problem that I work on from time to time, and this is actually a real world problem where a lot of cities, they have certain projects in mind, and sometimes these projects are proposed by the residents themselves, and so there is maybe a project about building a new museum that costs 4 in some currency, some units, and there is a project about renovating roads in some neighborhood that costs 1. There is a project about building a new park, costs 3, and the city has a total budget of 4, which means that the city can only fund either building the new museum or renovating the roads and creating the park. And then the city asks the residents how they prefer these kind of 3 different projects. There are different ways in which cities usually do this. Most of the time, they ask residents to just approve certain projects. So say like approve 3 projects out of this list of 10 projects. And there's like a whole process that goes into filtering down from like 100 plus projects that are initially proposed down to 10 projects that people can actually vote over. So this is not like the whole picture of the entire process. But let's say that we have some more expressive preferences where people can actually indicate the intensity of their preferences. And once again, you can define the core here. Really, you don't need these kind of values. All you need are preferences, whether somebody prefers some solution more than another solution, right? So you don't really need the exact numbers. And so here, once again, if you take any 20% of the population in the whole city, they would feel entitled to 20% of the budget serving them. And now this 20% may not necessarily be from some neighborhood. So I mean, you might think that a primitive solution is to just divide up the divide up the budget between different neighborhoods and just kind of let each neighborhood decide what they want. Because there are other groups of interest. So for example, parents might want the budgets to be allocated to more educational projects, right? Or people who are living along the river that passes through the city might want the budget to be spent on kind of development along the river, kind of developing parks along the river and so on and so forth. So there are a whole bunch of overlapping groups that we are interested in, which is why this definition of core ends up being really interesting for this problem. And in my kind of conversations with various cities, they really like this notion. The problem is that we don't have a compelling solution to this. We have some guarantees for how close we can get to achieving the core, but we don't know these guarantees are not good enough yet. And just to kind of show you the scale of the problem, this hardworking people of the World Atlas put together kind of a big report where they showed more than 11,000 instances of participatory budgeting that have already happened across the world. And here's kind of a map of all the different cities in the world that are doing this. And this is a pretty old map. I believe that this is 2013. And so, I mean, even US is a lot more filled now. There are probably, I think, more than 50 cities in the US that are already doing participatory budgeting now. And the scale in terms of money is also pretty big. For example, Paris allocates more than, I think, 100 million euros every year through this process. So it's a really important problem if some of you want to work on it, because there's no good solution, and a lot of cities are right now just using simple heuristics. All right, so what does the core say? You divide the budget, whatever budget B that you have, equally among all the N residents, right? Hypothetically, and now any group of L residents should be able to come together, pool their own entitled share of the budget together, and so that's going to be L divided by N times B amount of budget. And using this budget, if they can find a certain set of projects to fund that fit within this budget, and funding those projects actually is a Pareto improvement for this group over whatever projects the city is funding, then again this group has a legitimate complaint. And we know that the core cannot exactly be achieved. I believe the best lower bound that we have for this is 2. We know that you cannot do better than 2 approximation of the core, but the only upper bound we have is something like log m, where m is the number of projects, and there's like a big constant hidden in there. So in practice, this ends up being pretty terrible. There is a different method that a few researchers have recently started actually deploying with a whole bunch of cities across the world, which achieves a two approximation of the core, but using a slightly different notion of what an approximation is. Okay, but it just kind of shows that a lot of cities are really interested in this particular fairness notion for the context of participatory budgeting. All right, let me take a few moments to talk about a different application which many of you might be kind of more associated with, which is conference peer review. And so you have these large conferences like NeurIPS and AAAI, ICHCAI, and these conferences bring together so many different communities, and all the people from all these different communities are submitting their papers to this one common conference. And the reason, at least one promise of these large conferences, is that sometimes you might be working on some paper, you are part of one or maybe several communities, and you are working on a paper that is actually a more kind of interdisciplinary paper, and reviewing this paper, providing high quality reviews for this paper requires expertise that are not present within your community, or at least kind of maybe there are enough interdisciplinary papers going on that there is some expertise within the community, but there are not enough people to provide all these reviews that take all these other aspects into account. And so by having this large conference where people from different communities come together, hopefully we'll be able to match each paper with, this is again like very ideal hope. We know that for a lot of reasons this doesn't work as well as we want it to work, but that's at least the promise that you should be able to take each paper and assign it to reviewers, sometimes potentially outside of the community from which it was submitted, and get high quality reviews. And once again, the notion of the core becomes somewhat interesting here, because if there is a group of authors who maybe belong to a community, and if they consistently feel that their submissions are not being assigned to reviewers who are able to review those submissions and provide high quality reviews, then they would have an incentive to just break off from the system, set up their own little conference, and then this is going to, assuming that your there was a way to actually run the huge conference and provide high quality submissions, this would be a worse outcome than that, and it would be a less cooperative outcome than that, right? So what the core tries to achieve in this context is again this notion where if you take any group of people, they shouldn't be able to achieve something better on their own than how the system is treating them. Okay, but here it's not a notion of entitlement. They are actually bringing something to the system, which is the reviewing capacity, right? So all these authors, they are also, some of them at least, are also serving as reviewers for the conference, and so this community is not only submitting papers to the conference, but also contributing this reviewing capacity. And by deviating with their own reviewing capacity, they shouldn't be able to achieve a better outcome, right? So what we did in Anna's paper this year is we took started with a very restricted model of conference peer reviewing, where you have a set of authors, and some of them are also serving as possible reviewers for the conference, and each author I submits a set of papers to the conference. So that means that these are single author papers, and obviously this is not very realistic. Maybe it's a little bit more realistic for grant proposals and being reviewed by different faculty members, but certainly less realistic for conference peer reviewing. But there is a significant challenge in extending our techniques to multi-author submissions, so that's an open question. And then we obviously want a feasible reviewing assignment, so we want some kind of validity constraints that each paper is assigned to enough reviewers, each reviewer has not too many papers, and obviously some conflict constraints are respected. And we have to make some assumptions on some kind of we have to put some mild constraints on the preferences of the authors over which reviewers should be assigned to their papers. And then the notion of the core would essentially say that, as I said, no subset of authors should be able to deviate with some subset of their submissions, assign it within themselves by respecting those same kind of validity constraints from before, and achieve a better outcome. And then we are able to show that at least in this very restricted model, a reviewing assignment that satisfies the core always exists, but isn't achieved by any of the existing methods. You actually have to do something. It's a very intuitive method, but it's different from what's being done. But obviously, this is an unrealistic model,
And there's an open question on extending these techniques to more realistic models of peer review. All right, so those are 3 example domains that I wanted to talk about for the context of the core. And obviously, this definition is meaningful in a lot more domains, and there is already some work on looking at it in various other domains. So some of the more collective decision-making domains are estate division that I mentioned earlier, where we had a paper in AAA 2019 where we did that. In voting, where we looked at this in an EC 2022 paper, and actually 2 of my students have a paper under submission which looks at it in a different problem called sortation, which is something that's used in the real world to build citizens' assemblies that deliberate over certain issues and then provide recommendations to policymakers. And I have an ongoing project on looking at this in the context of automated redistricting as a solution to the concern of gerrymandering. And then this has also been looked at in some machine learning, other machine learning domains like federated learning. There was a NeurIPS 2022 paper, classification, this AI Stats 21 paper, and then I have an ongoing project on looking at this in the context of regression. And in all these domains, this definition ends up being meaningful and highly non-trivial to achieve. All right. So that was more about how do we get people to cooperate, but we also need to answer questions like who do we want to cooperate? And for this, I just want to make kind of one point that I think I mean all of you know and many of you might agree with, which is that we want to first understand the natural synergies between different agents, because they dictate which agents are going to be more likely to cooperate on their own, so there would be less barrier to cooperation. And so we had a paper back in AAA 2014, which I hadn't even, I had completely forgotten about until I started thinking about cooperation, and then this kind of paper made a natural sense, where we looked at weighted decision making within organizations like IMF and EU, where different countries come together. They each have a certain weight, and then they kind of vote over certain issues, and then if countries with enough collective weight are in favor, then the issue gets selected. And then countries care about kind of the influence that they have in this process, and this is usually captured by something like the Shapley value, which I don't know, some of you might know about the Shapley value. And so what we did is we looked at the change in the Shapley value of a given agent by the presence or participation of another agent, right? And so if there is a kind of, if a new country is hoping to join the IMF or the EU or the NATO, then each country might kind of try to reason about how much my Shapley value will change and in what direction it would change by this country joining the coalition. And so if my Shapley value is actually going to increase by this country joining the coalition, which very often happens, then I would want this country to join the coalition, which will be the kind of more cooperative outcome. But otherwise, if my value is going to go down, then I would want to kind of try and prevent this country from joining. And we kind of just by using this definition, which actually turns out to be symmetric in that context. So if I want you to join, you want me to join. So if there are 2 countries kind of hoping to join, they can kind of each reason about the other, and it turns out to be symmetric. And you can get some interesting intuitions about kind of which agents are likely to cooperate with each other. So in IMF, for example, we found that the high weight countries, the larger countries, they are generally cooperative with all the other countries. But the smaller and medium weight countries have a lot of kind of lack of synergy, and so that's maybe where you want to focus your effort on in inducing cooperation. In EU, it was a bit different. Countries with similar weights were the ones that were kind of more likely to cooperate with each other already, and the countries with different weights are the ones that had antagonistic relations. We had another paper, again, that I had forgotten about, but was recently reminded, was this NeurIPS 2014 paper, where we showed that diversity beats strength. So Lewis mentioned about like all these foundation models that we have that are kind of the same pre-trained model, but slightly different fine-tuning or slightly different kind of supervised learning on top of that. And here what we showed is that if you take a diverse team of weak agents, and so these agents are not so good at solving a task, but they are very diverse. They are based on very, very different ideas. So think about like very different foundation models to begin with. They are actually better at cooperating and solving a task collectively than a team of much stronger agents that are less diverse. So think of like a much better foundation model that generally gets much better accuracy, but then the team just consists of kind of different fine-tuned versions of the same foundation model. And we showed this in both in a theoretical model, but also in experiments with Go playing agents. This is a computer game Go, which people were working on at that time. All right, and why should we kind of want the agents to cooperate? So we need to demonstrate some kind of gains from cooperating, which is something that Lewis also mentioned, maybe kind of in a different formulation, that we want to demonstrate failures and how much you can lose if there is a failure to cooperate. And so we had this Ichkai 2013 paper where we looked at Stackelberg games or security games where security agencies like the Coast Guard or the border patrolling agencies, they are trying to prevent some real-world targets from an attacker, and often kind of these agencies don't cooperate with each other because they don't want to share information with each other. And what we showed is that because of this lack of cooperation that actually exists in the real world right now, these agencies are not cooperating. We showed that this can actually lead to arbitrarily bad collective welfare. In fact, arbitrarily bad individual welfare because they are not sharing information with each other, and they're just kind of deploying these patrol units without coordinating with each other. And even in kind of very special cases, this can be really bad. And then we had some simulations using actual setup and data from the ports of Boston, where we showed that even in practice, kind of in theory, it can be arbitrarily bad in the worst case, but even in practice, these agencies can end up losing utility defined in terms of like how well they are able to protect these targets by a factor of like 2 to 3, which for these agencies is kind of really significant. Because if you are going to be able to protect these targets like 90% of the time, and suddenly now you are only able to protect them 30% of the time, that factor of 3 is a huge kind of loss for them. All right, so I know that I'm a little bit over time, so I'll just end with a few very quick food for thought / takeaways. So one is, as I said, that it's important to concretely be able to understand and define what it means to cooperate. Right, and how do you define it? So here we define it in very simple resource sharing systems where the definition of cooperation was very easy. We've kind of focused more on how do you induce people to cooperate. How do you define it in more general settings? And it's kind of, this is a very hard problem. We already talked about this earlier. I'll just highlight that there is need for diversity of definitions. And this is something that people in the fairness world have recently started kind of realizing, that each fairness definition, there is no right fairness definition. Each fairness definition is preventing you from imposing a certain kind of harm on society. And so what you really want is solutions that satisfy a whole bunch of fairness definitions all at the same time. And similarly, there might be kind of different failure modes for cooperation, right? And you might have different definitions where each definition is trying to mathematically capture a particular failure mode for cooperation. And then you want solutions, or you want AI systems that satisfy all of these different definitions at the same time, so that you can prevent multiple failure modes of cooperation all at the same time. Okay, so there's at least some conceptual borrowing from the fairness literature that you can do for understanding cooperation. And to do this, you often need to kind of analyze the impact of your decision on everybody else and on yourself. But in some contexts, that impact may not be clear yet. The change in everybody else's utility because of me taking this action may not be clear yet. And in the fairness literature, this is often kind of a problem that people have dealt with, because if you design a translation module, you don't know who is going to use this translation module, how they are going to make decisions based on this translation module, and then how those decisions are going to affect different humans. And so what you do is you design some kind of proxy functions that very highly likely are going to correlate with the eventual impact that things can have. And then you are going to define your fairness definitions based on those proxies. And again, that idea can also be leveraged to understand cooperation, right? And then just last food of thought is that different people might disagree on what cooperation means. And it's important to handle these normative disagreements between different people's understandings, intuitions, or definitions of cooperation. And how do you do that? Well, one thing that the fairness literature has tried to do, because of the same issue arising over there, is to take this kind of multi-perspective definitions, where you try to find a solution that everyone will simultaneously agree is fair from their own viewpoint. Okay? And so something like that would be a worthy goal in the cooperation field as well, where you try to find a solution that different entities or different participants will all find is kind of cooperative. And so, for example, Lewis talked about climate change negotiations between different countries. And so countries would want to cooperate, but you would need to find something that the countries would feel fair, is dividing the burden of addressing climate change fairly. And again, the different countries might disagree as to what is fair. All right. So let me end that the presentation here, and I would be very, very happy to welcome questions, which I believe Lewis is going to be the dictator on selecting questions.
So most top-voted question at the moment is that there are all sorts of impossibility results in computational social choice, and how important or discouraging do you think these are for the project of cooperative AI?
Yeah, that's a very good question. I mean, there are famous impossibilities like Arrow's impossibility, Gilbert-Suther's fit impossibility that people know of. So there are two things here. One is that many of these impossibility results are because these notions, some of the desiderata, in fact, both these impossibility results are qualitative. You either are doing this or you are not doing this. And some of my work has definitely kind of tried to go around it by specifically looking at notions that are more quantitative, or at least kind of looking at relaxations of qualitative notions that make them more quantitative, right? So yes, you cannot achieve the core, but that doesn't stop you from trying to go close to the core and at least achieving some approximation of it, right? And so a lot of these kind of early results in social choice theory were from economics, where kind of if you're not achieving this notion, then all is doomed, right? But in more the latest kind of computer science based approach has been looking at, okay, there is an impossibility, you cannot achieve all three notions at the same time. So let's look at the Pareto frontier of what approximations of these notions can be achieved all at the same time. And so how close can we get to achieving all these notions at the same time? And the same happens in the fairness literature as well. I talked about trying to satisfy different fairness definitions at the same time. There are really fundamental impossibility results that have been realized in the last 7 to 8 years, where people have shown that certain fairness definitions are at fundamental odds to each other. But once again, you can try and satisfy them approximately all at the same time.
Thanks. Next question I have on here is, we often assume in cooperative game theory that the grand coalition of all players does in fact form, and then the job is to kind of allocate the payoffs in such a way as to satisfy various constraints and so on. But in practice, we might get kind of competing factions. We might not get the grand coalition. And so the question is about kind of what can we do to encourage the grand coalition?
So that's a very good question. So when the grand coalition doesn't form, there is kind of a different field of cooperative game theory called like coalitional structures, where you actually analyze what coalitions can form and what coalitions should form. But that's a good question as to kind of how do we move away from that and still kind of somehow like get the grand coalition to form. So this approximate core takes kind of it doesn't answer that question. It answers kind of the question after that, which is that if the coalitions are willing to sacrifice some private utility in order to participate in this grander system, and so maybe they have like a sense of empathy, maybe they have some sense of public spirit, where if it's good for the society for me to participate, then even if there's this different outcome that I can achieve using only my entitled or my contributed share of the resources, that's maybe like twice as good for me, I would still participate, right? So that's one way of looking at what approximate core means, right? That if these agents or these groups of agents, they have some sort of public spirit, then at least if you can achieve an approximate core solution, then the grand coalition would still form, right? Now, how do you actually induce this public spirit if it doesn't exist in a given domain? And so in social choice, people have looked at, for example, voters kind of trying to cooperate with each other, and instead of each voter individually kind of voting over what's best for me, trying to get voters to think about other voters. So especially in the participatory budgeting context, this is very important. And the cities, what they do is they kind of get people together and have them deliberate over kind of the different projects, and kind of get people to express their preferences and have other people hear those preferences. And so what happens is that maybe I'm living in one neighborhood, I really want a park in my neighborhood and I want the city to spend money towards that. even though I have a different park in my neighborhood, but I just kind of want to have some more options, right? And then I go to this meeting, I hear about people from this other neighborhood, and they are not, maybe they don't have as many opportunities, and so many of them don't own a car, and there is no bus route going through that city, that part of the neighborhood, and they really want the city to spend money towards that. And once I learned that, maybe I would say, you know what, yeah, if you are really going through that much hardship, I mean, I can make do with the one park that I already have, and then I will also vote in the election that the city should spend its budget on that, right? So this kind of deliberation between different agents and kind of just getting the agents to communicate to each other, that can sometimes lead to some sort of public spirit.
Nice, thanks. Next question is, how would these kind of definitions and concepts work in general open-ended settings where there aren't well-defined utility functions?
Yeah, that's a good question. That's partly kind of one of the reasons why utility functions may not be well defined is because you don't know them yet. The other reason why they may not be well defined is because there are utility functions, but this is the kind of settings where humans are very kind of, you want to elicit this from humans, and humans are very bad at expressing their utility. So for example, if I ask you, what's your utility for going to lunch at the Meridian restaurant, I mean, it's unclear, like how, in what scale do you represent this utility? Do you kind of represent it in dollar terms? Do you represent it in some other scale, some other units? And so if that is the case in a lot of settings, I mean RRHF being one example, right, where if people are having a hard time representing, kind of giving quantitative feedback, sometimes you can just get ordinal feedback from them. You can get them to compare different options, you can get them to rank different options, you can get them to approve certain options, and then by using that, you can sometimes actually I mean, just in RLHF, for example, you learn a reward model that kind of matches people's ordinal preferences, and in some sense you turn those ordinal preferences into some more quantitative preferences. Sometimes you can, maybe you cannot really ask them the utility functions directly, but you can get some sense of it. You can ask them if kind of you like this option significantly more than this option, etc. And so there is a lot of work in psychology on how to kind of effectively elicit people's preferences kind of more quantitatively but still accurately. So maybe we can look into that.
Cool. Okay. So I think we'll have time for just two more questions, and then we'll close for the break. So first of these two questions, how should we think about resource entitlement in context with power differentials? So e.g. in context where some agents can threaten other agents.
Yeah, that's a very good question. So in some of these systems, so kind of in the type of systems that I mentioned here, for example, participatory budgeting, the city is trying to achieve an outcome division of the budget that's in the core, and the city is not kind of really going to each individual and asking, how much do you feel you are entitled to a share of the resources? So even if there is some other agent that's threatening this agent and trying to convince them to believe that they are not entitled to any share of the public budget, the city doesn't really even, isn't even concerned about that. The city just kind of imposes that every resident is entitled to an equal share of the budget. So that kind of, I guess, is one very ad hoc and very kind of crude way of approaching this problem. You kind of take those opportunity away and you just impose a normative solution saying that everybody is entitled to an equal share, and so that kind of like eliminates the, there's still obviously opportunities for coercion in terms of how you are then going to use your entitlement and how you are going to vote. Right, so I can come to these meetings that I just mentioned, and I can like kind of either tell you a sob story about how my neighborhood needs this budget that isn't actually true, or I can kind of threaten you that if you don't vote a certain way, then I'm going to kind of do something bad to you. So that's those are the kind of things that people in very different literatures have looked at. People in social sciences have looked at, actually, particularly in the participatory budgeting context. So that's something that we can also look into for the context of cooperation.
Cool, thanks. Okay, so final question, let's close this out, is how would we approach systems where we only have control over a finite set of agents? So there are external agents that we want to cooperate with, but we can only maybe kind of design mechanisms, think about allocations, etc., or maybe things within a finite set.
Yeah, that's a very good question. So I suppose even in this framework, when I defined capital N as the set of all agents, it could just be the set of all agents that the system has a control over, right? And the whatever allocation the system does to this set of agents could actually have externalities to the other agents out in the world. I mean, even in participatory budgeting, right? So this, you look at the set of residents in a city, but whatever that city does could have externalities elsewhere. And so that's a very interesting question as to how do you get those agents to then kind of, I mean, once again, like if you have some sort of public spirit, or if you can induce some sort of public spirit, then you can maybe get those agents to care about the welfare of the agents who the system is not able to control, and then you can get those agents to act in a manner that's kind of good for everyone collectively, and again, you can kind of use some sort of awareness campaigns, some sort of deliberation to induce that kind of public spirit. And I'm sure that like other literatures have answered this question on how do you get certain agents to kind of think about certain other agents, and then so yeah, you can look into those literatures.
Okay, thanks very much, Nisarg. That's all the time we have for questions this time. So if we could just give one more round of applause, please.
Thank you, everyone.